Let a, b, c be positive real numbers such that a, b, c equals 1. Prove this statement. So first, a common idea for a, b, c equals 1 to homogenize the inequality is to substitute x over y, y over z, comma z over x, because this automatically satisfies this. However, there's actually an easier method to solve this problem. We can substitute a equals, because we notice that lots of things are on the denominator, so we can try to get them to the numerator by substituting this. So basically, we just take the reciprocal of all the numbers and replace them with x, y, and z. So if we plug this in, we get the first term is 1 over x cubed times y plus z over yz, which is just so it's x cubed yz over y plus z. And since ABC equals 1, we know that 1 over xyz equals 1, so that means that xyz equals 1. So that means that this thing equals x squared. So it's actually just the sum. The cyclic sum is basically saying it loops through all the variables. Like this is just the first term, but there's similar expressions for the next two terms. And we want to prove that this thing is greater than or equal to 3/2. So we can use T2's lemma, which says that this thing is greater than or equal to x plus y plus z squared over 2 times x plus y plus z, because each term appears twice when we're summing all of these. And so this equals x plus y plus z over 2. So the problem is done if we can prove that this thing is greater than or equal to this. Clearly this is equivalent to showing that this is true. But this follows by the AMGM inequality because x, y, z equals 1. This completes the problem. Thanks for watching.